Welcome to the lecture series. So in the previous lecture, we have discussed about the overview of a microcontroller, that is nothing but the 8051. Now we are going to discuss in depth of this memory organization. As we know, 8051 has an inbuilt memory of RAM and ROM. So it has both volatile and non-volatile. So ALU itself doesn't own memory but interacts with the memory through the processor. So the role of memory organization is limited for the accessing operands and storing results via the registers or interfaces. So now we have to discuss about what are the types of memories we have in this microcontroller. First of all, coming with the registers. Registers are nothing but a small storage device, and here we can store up to 8 bit. From starting from 8 bit we can go for 62 1 32 bit. So it is directly accessible by the ALU, that is nothing but arithmetic logic unit. For example, accumulator, general purpose registers, status registers, and these status registers are used for flags like to carry 0 or 1, and organized as a small fixed of a memory cell within the CPU. And role in this memory access is this receives operands from the register or memory via the memory CPU's memory bus. Results are written back to the registers or memory. So we have memory. Apart from that, to act as a temporary memory, we have this registers. And there is no independent memory. The ALU relies on the microprocessor of the controllers and for the data storage. And you can find like from CPU we have registers, CPU caches, main memory, secondary memory, territory storage. So if you can see the fast access speed from CPU to register, it is more accessible and it is reachable. When it goes for the cache level, somewhat it is difficult level. If we go for the RAM level, there is more level 1, level 2 to fetch the data. And if it is in the secondary, we have more slower retrieval time. And if you go for the territory storage, we have still slower time to retrieve a data. For example, if I have an data in the mobile phone itself, the retrieval will be very fast, right? Or if the data is in some other secondary storage like your drive or pen drive, we have to go for a search of a drive, and the retrieval of time will be taken. So that is the faster access to slower access. But the capacity from the register to the territory, you can see the level of capacity is increasing. So primary storage, on chip storage is nothing but your CPU register, CPU cache, and RAM is a volatile, you can access it. And secondary disk, that is auxiliary storage, comes under your secondary storage and territory storage. Coming to the register, as we discussed, it is the fastest memory inside the CPU, and we have program counter, instruction register, accumulator, general purpose registers, etc. And it is used as a temporary storage like instructions, commands, and results. And size varies like 32 for 8086 and 64 for the modern CPUs. Second thing is a cache memory. It is a small, fast, short, short RAM located close to the CPU and organized in the level 1 to 3 with the increasing size and latency, and it can store frequently accessed data or instructions to reduce the time to main memory, and it is fully associative, set associative or directly mapped. Next comes under your storage, secondary storage interface, that is your say HDD, SSD, and via you can access that via to the input output controllers, and this is not a part of a core memory organization but used for a long term storage. And coming to the main memory, there is RAM external to microprocessor accessed via the micro memory bus, but in the microcontroller you can find it inbuilt and organized as a linear address space, like a 4 GB in 32-bit systems. And you can find it in divided segments like code segment, data segment, and stack segment. It stores program instructions, and data segment stores the variables and data. Stack segment manages the function calls and local variables, and last one is a heap segment for the dynamic memory allocation. And you can have a comparison of the memory organization across the ALU, microprocessor and microcontroller. So primary memory, you in ALU you have only registers, in microprocessor you have register, cache, external RAM and ROM, whereas microcontroller you have on-chip RAM, ROM, flash and EEPROM. Memory size also few bits, megabits GB, where it varies from KB to MB in on-chip. Architecture, there is no specific architecture for ALU, and processor you have non-human and modified hardware. Here you can use hardware, mostly they are used or the one human. Memory access, ALU will access via the CPU registers. This processor will act via the memory bus. Microcontroller, it is inbuilt, so on-chip direct access. Purpose is ALU is a short storage and processor is a general purpose computing. So controller is a task specific, so it needs a memory. Examples of failure: part of a CPU, processor Intel i7, ARM Cortex A, etc., where controller comes under the PIC, STEMP32, ESP32, etc. In the next lecture series, we will discuss about the instruction sets in the microcontrollers. Thank you.